Assalamu alaikum. We're going to be going over the concept of arithmetic progression and geometric progression. So let's start with arithmetic progression. Okay, so you have already seen arithmetic progression in O levels. Let me give you two examples of arithmetic progression. Let's say the first term is 3, next term is 5, next term would be 7, then 9, then 11, and 13, and so on. This is called an arithmetic progression. Like I said before, you've already seen this in O levels. Let me give you another example. How about a term that starts with, let's say, 9, next term is 6, next term is 3, next term is 0, then minus 3, then minus 6, and so on. This is also an arithmetic progression. Okay. Why are these called arithmetic progression? Because there's a common difference in both of them. The common difference here is represented by D, and it is plus 2. Because we see if we add 2 to the previous term, we get the next term every time. And for this one, the common difference is negative 3. Because if we subtract 3 from a term, that's how we get the next term. Similarly, both of these have their own first term. First term of this series is 3. The first term of this arithmetic series or arithmetic progression is 9. Now you have enough information to form the nth term of the arithmetic progression. The formula for nth term is same as O levels, now represented with UN. So now it's just a fancy way of saying an nth term, which is UN equals A plus D times n minus 1. So the nth term of this progression would be A is the first term 3, D is the common difference 2, times n minus 1. And for this one, the nth term is going to be 9 minus 3 times n minus 1. And you will expand the brackets and get 2n plus 1 here. And you'll get minus 3n plus 12. Okay, so you've already seen this in O levels. And now, if you have the nth term formula, then you can find the fifth term of the sequence by replacing n with 5, or the eighth term of the sequence by replacing n with 8. Okay, so this was pretty much like O levels. Now let's move on and talk about more advanced concepts in arithmetic progression. Okay, so along with finding the nth term formula or using the nth term formula, you should also know the formula for sum of n terms, which is represented by Sn. Sum of n terms. For example, if I say I need sum of 1, 2, 3, 4, 5, 6, sum of the first 6 terms. So then I'm going to say n6. Or if I want the sum of the first 80 terms of the same sequence, then I'm going to say sum 80. Or the sum of the first 14 term of the sequence, then I'm going to say S14. So there's a formula to find sum of first n terms of this sequence. Okay. Now the formula is, there are actually two variations of the formula. The more commonly used formula is going to be n over 2 times 2a plus d bracket n minus 1, this formula. This will be used when you will have n, a, and d, and you'll be asked to find Sn. Or you may have any three of these and one would be missing. For example, sum of n terms is given, n is given, d is given, and maybe they'll ask for a. So if you have N, A, D, and Sn, or any three of these, and the fourth one is a missing quantity, you will use this formula. And there's another variation to this formula. You can also find sum of the first n terms of an arithmetic progression using this formula, n over 2 times a plus l, where n is the same thing, the value of n, a is the same thing, the first term, l here is the last term. Now, what do we mean by the last term? Let's look at this same series. This is 3 and this is 7. Okay. So by last term, I mean, let's say they give you the series and they tell you that find sum of 1, 2, 3, 4, 5, 6. Sum of these 6 terms. So now the question is such that you have the last term as well. Last term is 13. And the first term is 3. And n is going to be now 1, 2, 3, 4, 5, 6. These are 6 terms. So we also know that n is 6. So now you can instead use this formula as well to find sum of n terms, because you have n, which is 6, you have a, which is 3, and in this particular question, you do have the last term as well, which is 13, because they're asking for the sum of the first 6 terms only. So we know what is the 6th term. So if you know the last term or the nth term of the series, then you can just use this formula. Otherwise, like I said before, this is the more commonly used formula, because the last term is usually not known in the past paper questions. Okay, so let me try using this formula. Okay, so let's say we have to find sum of first 25 terms of this sequence. So then we know n is 25, we know a is 3, d is 2. So just plug in the values. S20 would be 25 over 2 times 2 times 3 plus d times n minus 1 would be 25 minus 1. And enter these values in the calculator and it will give you sum of the first 25 terms of the sequence. Let me just double check. N is 25, A is 3, D is 2. Yeah, looks good. So just enter all of this in the calculator. Let's see what we get. Fraction 25 by 2 times 2 times 3 plus 2 times n minus 1. So that's going to be 24, bracket close. I'm getting 675. So the sum of the first 25 terms of this sequence is coming out to be 625. All right. Now, to step this up, they might ask you something like this instead. Find sum of the values. Yeah, find the sum from the 20th term to the 25th term. Find the sum from 20th to 25th term. So they also twist the questions like this. So we know how to find sum of the first 25 terms, which is the formula S25, which we just applied, which came out to be 675. But what is this? They're now asking us to find the sum of the 20th term and 21st, 22nd, 23rd, 24th, and 25th term. So we have to find sum of these 6 terms now. not all the terms from the first term to 25th term, but only the terms from 20th to 25. So now what do? You find S25 like usual, but then you also subtract the first 19 terms from the series, the sum of the first 19 terms of the series, because you only need the 20th, 21st, 22nd, 23rd, 24th, and 25th term. So we don't need the sum of the first 19 terms, so you subtract from that and apply this formula. Apply the formula of Sn two times, one with S25, then with S19 or N19, and then subtract the values. Let me show you how. So the sum of the first 25 terms would be the same as before, 25 over 2 times, by the way, we're still talking about this left series. So times 2a plus d, which is 2 times n minus 1, which would be 25 minus 1, bracket close, minus 90 over 2 times 2a plus d, which is the same 2 times n minus 1, which is going to be 19 minus 1, bracket close, bracket close. So whatever this is will give you the sum from the 20th value till the 25th value. One more thing we need to discuss regarding arithmetic progression is how to form an equation if we have three consecutive terms of an arithmetic progression given to us. Let me repeat that. So, given three consecutive terms of an AP means arithmetic progression, are, let's say, X, Y, and Z. Three consecutive terms of an arithmetic progressions are X, Y, and Z. Form an equation connecting X, Y, and Z. So there are three consecutive terms of an arithmetic progression, X, Y, Z. We need to form an equation that has all three of these X, Y, and Z. Let's look at another arithmetic progression. Let's say it starts with 3, 7, 11, 15. Okay. So this is an arithmetic progression where A is 3 and B is 4. Okay. And look at any three consecutive terms of the arithmetic progression. I'm looking at these three consecutive terms. So notice that the common difference is the same. This difference is 4. So is this difference. So if I'm to connect three consecutive terms of an arithmetic progression into an equation, I can do this. That I know that the difference of the third term and the second term will be the same as the difference of the second term and the first term. So difference of these two must be the same as difference of these two. That is how I've connected 15, 11, and 7 in an equation. Now let's go back to X, Y, and Z. These are the three consecutive terms of an arithmetic progression. You have an AP before that, and it continues after Z as well. But you're only given any three consecutive terms in between the series. So then we know that the difference of these two, Z minus Y, should be equals to the difference of these two, Y minus X. And there we have it. We have connected any three consecutive terms of an arithmetic progression through an equation. You may simplify it now. It becomes Z plus X equals 2Y. And Rest we'll see in the past paper questions, that what kind of questions come up regarding this topic. But for now, you need to know how to connect three consecutive equations, three consecutive terms of an arithmetic progression. You use the difference concept shown here. Okay, I think we've discussed arithmetic progression enough. Now let's move on to the next progression, which is geometric progression. Okay, I don't know if geometric progression is in O-levels syllabus. I'm sure that it's in IGCSE syllabus because that's what I teach, but it might also be in O-level syllabus. I'm not sure, but it wasn't back in the day when I used to teach O-levels, so I'm not sure. So let me show you an example of a geometric progression. Let's say there's a term 2, and then there's 4, and then there's 8, and then there's 10. Sorry, not 10, 16, and then there's 24. And so on. So notice, just give me a second, and it's not 24, it's 22. Sorry, this is 32, not 22. And then the next term could be 64. Okay. So this is called a geometric progression because when you get the next value by multiplying the same value every time, you get a geometric progression. So we see that if we times 2 with the previous term, we get the next term. So in this, the nth term formula is A R power n minus 1. A is the same thing, the first term. So this would be A. It's the first term. R is the common ratio. So R in this case is 2 as well, but that is this 2. And n is the number of term. So the nth term for this series would be A times R is in bracket, power n minus. So now if you have to find, let's say, the 21st term, so then you're going to do 2 times 2 power n minus 1 is going to be 21 minus 1, which is 20. That's how you're going to find the 21st term of the geometric progression. If you have to find R and it's not that obvious, here it is, definitely it's 2, we can tell. But if, let's say, it's in decimals or if it's in fractions, then you find R through this formula. You take any term, so you take a term divided by its previous term. So you can take the second term, like we have 4 here, the second term, and its previous term, which is 2. So we get R is equals to 2. Or you can take this term, 32, and then its previous term, 16. So you get 2. That's the formula for finding R. Any term divided by its previous term, in case R is not obvious in the question. Okay, so now that we've discussed the nth term formula, let's also discuss the sum of n terms formula. Sum of n terms. This formula is A bracket 1 minus R power n upon 1 minus R. By the way, all these AP, GP formulas are given in the formula sheet, so you don't have to worry about memorizing them. But if you can, that would be great, but it is given. Okay, so now let's find the sum of the first 50 terms of this sequence. So that's going to be A is 2, 1 minus R is also 2, power 50 upon 1 minus 50. And your calculator will do the rest for you. Similarly, in case it asks you to find the sum of terms between, let's say, the 17th term and the 21st term, you need sum of the 17th, 18th, 19th, 20th, and 21st term. So then we use the same formula we discussed earlier. We're going to take sum of the first 21 terms minus sum of the first 16 terms, because we need to start from 17. So this would be same, a is 2, 1 minus r is also 2, power n, which is 21, upon n minus 1, which is 1 minus r, minus sum of the first 16 terms. So it's going to be 2, 1 minus r, power n minus, sorry, it's not n minus 1, it's just n, upon 1 minus r. And again, the calculator will do the rest for you. Okay, remember this is n, not n minus 1. I hope I did not say n minus 1 somewhere in the previous example. In case I did, please fix it. This power is supposed to be n, not n minus 1. So if you're finding sum of the first 50 terms, this would be 50. Okay. Okay. Now let's talk about sum to infinity. There's also another concept in geometric progression, which is sum to infinity. And it has its own formula, a upon 1 minus r, also given in the formula sheet. And with that, they write modulus of r is less than 1. Let's take a while to discuss what is sum to infinity. Okay. So let's look at this term again that we discussed earlier. This term keeps on increasing, like it's times 2. So it keeps getting bigger and bigger and bigger and bigger. So it's called a diverging terms. It starts with 2, then becomes 4, then becomes 8, then becomes 16. So it diverges. It keeps getting bigger and bigger and bigger. You cannot find sum of all the term or in this sequence. If somebody says find sum of all the terms in this sequence, it keeps going on and on and on and on. It's not stopping anywhere. So how can you find the sum of all the terms of the sequence? It's an infinite term. And it keeps increasing and increasing and increasing. So there is no concept of finding the sum of all the possible terms in the sequence. So that does not make sense. But if a sequence instead looks like this, it keeps decreasing. For example, first term is 6. The second term is 6 divided by 3, which is, let's say, 2. Then the next term is, let me just use a better example. Let's say the first term is 8, and then it becomes 4, and then it becomes 2, then it becomes 1, then it becomes half or 0.5. So what's happening now? Every term is becoming smaller. Why is that? Because r is what? A term divided by its previous term. So r is half. So the term keeps getting halved. 8 gets halved, becomes 4, 4 gets halved, becomes 2, and so on. When 0.5 will get halved, it will become 0.25. So eventually, when this keeps happening for some amount of time, this becomes smaller, 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 smaller. Eventually, it becomes 0. So now this is not a converging term. Instead, it keeps decreasing. So first term was 8, then it was 4, it became smaller, then it became 2, then it became 1, then it became 0.5, 0.25. So it's a diverging sequence, and eventually it becomes 0. Started at 8, so this is the y-axis, 8, and it ends at 0. So it's a diverging sequence. And now the number of terms are finite. You can find the sum of all the terms in the sequence. because it stops at a point. When it becomes zero, it just stops because zero times half is zero now. So you can find sum to infinity. Sum to infinity means sum of all the terms of a diverging sequence. So sum to infinity means sum of all terms. And it's only applicable in a diverging, that means a decreasing sequence or a decreasing geometric progression or geometric sequence. Let me write G, decreasing geometric sequence. Okay. And by decreasing geometric sequence, we mean this, that the R can be, the magnitude of R can only be smaller than one, like half, or maybe 2 by 5, or maybe 3 by 8. So the numerator must be smaller, denominator must be bigger, so that the next term is smaller than the previous term. Also, you may write it like this. R is between 1 and minus 1. So if the value of R is between 1 and minus 1, only then the question will ask you to find sum to infinity. And the formula is this given right here. So let's use this formula. A is 8 upon 1 minus R is half. So the sum of infinity or sum of all the terms of this sequence is going to be 16. One more thing that is left to discuss is how to connect three consecutive terms of a geometric progression. So same question, a GP has three consecutive terms X, Y, Z form an equation in X, Y, and Z. Okay. So let's look at an example of a GP. Let's say there's a GP and one of its term is 3. Then the next term is 9. And the next term is 27. And there's more before that, and there's more before 3 and after 27. So three consecutive terms of a GP are 3, 9, and 27. And you have to connect these three numbers through an equation. So we know that if we divide these two, 27 over 9, it's going to give us the same answer of dividing these two, because the common ratio is the same, right? You multiply this with 3, you get 9. Then you multiply this with 3, you get 27. So 27 divided by 9 is going to give you the same answer as 9 divided by 3. So now let's do this for X, Y, and Z. So we know that if we do Z divided by Y, it's going to give us the same answer as Y divided by X. Cross multiply, we get Zx is equals to Y squared. And this is the equation connecting the three consecutive terms of a geometric progression. That would be all. We're going to start the past paper questions in class on Monday, inshallah. Thank you for watching. Allah Hafiz.